So, this one's really similar to some of the ones that we did in the last lesson. If you've got your coats on, if you wouldn't mind taking your coats off, please, that would be really good. Thank you. So let's read what it says. It says OABC is a square. M is the midpoint of OA, which we can see now. We know that that's exactly halfway. And Q divides BC in the ratio 1 to 3. So that must be 1 to 3 like this. AC and MQ meet at P. OA is equal to A. So from here to here, that whole thing is A. And OC is equal to C. Express OP in terms of A and C. So we're going to be trying to see how we get to OP. Now, what was the strategy that we used in these previous questions? Good. You're going to find two different routes to get to the point P. So which two routes did you use, Ishrak? You did O to A and then A to P. That's one of the routes that we can do. Yep. Yeah, the reason we can't then do O to C and then C to P is because we're using the same line twice. So we have to use, one of the routes has to use this line, this diagonal. The other route needs to use this line that we've got here as well. So it looks like the second route that we're going to do is going to go in the other direction. Come in. So second route we're going to take will go from O to M and then from M to P. I'm going to add a couple of other things on the diagram as well. We know that this bit has been split into half and half, and it said that the line Q divides BC in the ratio 1 to 3. So this bit is a quarter, and this bit here is 3/4. Okay, let's see if we can start building up some of these things. I'm going to start off with trying to find OP along the blue route. And the blue route goes from OA and then AP. So that's going to be from O to A plus A to P. Now O to A is just A, and A to P is going to be some fraction of A to C. So I'm going to use lambda of A to C. But I now need to find out what is the vector from A to C. How do I find out how you get from A to C? Yeah, it's minus A plus C, or you could say it's C minus A. So it's C minus A. So if I put that back in my expression that I've got for OP, OP is equal to A plus lambda lots of C minus A. So that's A plus lambda C minus lambda A. If I factorize the A part, I've got 1 minus lambda A plus lambda C. Okay, it's our first route that we can take to get from O to P. The other route has to use this other line that we've got here. It has to use the part of MQ. Otherwise, we're not going to be investigating how both of those lines are going to be intersecting. We'll only be looking at one of those things. So you have to make sure that we're looking at both of them. There are many ways you could get there. I think probably the easiest way is to go OM and then MP. So our vector that we're going to look for this time, which is we're trying to do the vector OP, we do that by going from O to M plus M to P. Right, well, do we know what OM is? Yeah, OM is a half A because it's halfway up that bit that we've got there. And MP, well, we don't know what MP is, but we know that it's some fraction of MQ. So I'm going to say that it is some fraction, which is my little letter mu there, and it's some fraction of MQ. But now I need to work out what MQ is. So I'm going to write in brackets here because it's almost like a bit of side working that I'm doing. How do I get from M to Q? So I'm here. What could I do to go from M to Q? Good. I could do this route that I've got. I could go half A plus C minus a quarter A, because they told us about the ratio there. So it's going to be, for MQ, it's going to be a half A to take me up, plus C, but then I'm coming back down a quarter A. So perhaps I'm going to want to simplify that, and a half minus a quarter is a quarter, so it's a quarter A plus C. Right, that's what my MQ is. So I'm now going to come back to the line that I had before, now that I know what MQ is, and I'm going to work it out. So I get that OP is a half A plus mu lots of a quarter A plus C. So we get a half A plus a quarter mu A plus mu C. What do we need to do when we get to this final stage? This is a bit people sort of forgot to do or found tricky to do, to factorise it, okay? So we'll have a look at taking the A out. We've got a half plus a quarter mu plus mu C. It's a lot of hard work to build up to this, but just to think about the logic of what we did here, we knew we had to go from OP in two different ways. I wrote out the route that I was going to take, and then I started finding out the bits I needed. If I needed to find anything extra, I either did this in brackets or I just did it somewhere else on the page. The reason I've put it in brackets is because if I had a larger piece of paper, I'd probably do it over the side so it didn't get in the way, okay? What do we do once we get down to this stage? This is almost like the part C of the question. Compare the coefficients. So I've got OP is equal to OP. These things here are equal to each other. So I'm just going to write that out. 1 minus lambda A. Notice how I'm always underlining my vectors. It makes the question look less confusing if you have all of the vectors underlined. And then we should be able to see by comparing coefficients that 1 minus lambda should be equal to a half plus a quarter mu. And the other thing we should see is that lambda is equal to mu, which is the nice one. That just makes it nice and easy. So writing those out, the green parts say that 1 minus lambda equals a half plus a quarter mu. My other one is that lambda is equal to mu. Any suggestions of the best way of solving those simultaneous equations? I can just input them. I can just, any time in this top one, I can change the lambda to mu if I want to. Although which one am I interested in? I'm trying to show that P divides AC in the ratio 2 to 3. So I'm interested in AC. Which one is that, lambda or mu? That was lambda, I think. The one that's to do with AC is lambda. So I actually want to find out what lambda is, which means that I should replace the mu with a lambda. So if I replace mu with lambda, I get 1 minus lambda equals a half plus a quarter lambda. Subtract the half, add the lambda. So a quarter plus 1 is 5 quarters. And then if you do times that by 4 and divide it by 5, you get lambda is 2 over 5. So that means the journey that we take along here is 2/5. And this journey therefore must be 3/5. So the ratio of AP to PC is 2/5 to 3/5. When you multiply that by 5, you get 2 to 3. And we also know that if lambda is 2/5, mu is also 2/5 as well. So this is also split into the same ratio, that this is 2/5, 3/5 as well, okay? Which parts of these questions do you think is the most challenging? Do you think is it the black part, the part that we do at the end, or is it the setup in the blue and red, the setup? Okay, so I think this is definitely one that's going to be worth you reviewing when you're looking back at your revision. You've got a couple of examples that I've done in a previous video. You've also got this example in this video as well, so that you get a chance to look at them again. You can't really do these questions in many different ways than those three that we've done. There's always going to be two routes arriving at the same point, using both of the diagonal lines that they're examining, and then comparing the coefficients. But it's a pretty tricky question, okay? So what we're going to do in today's lesson is we're going to finish off some things with vectors, and then we're going to do a little introduction to mechanics. And then for the next few weeks, I'll be teaching you the topics that there are in mechanics as well, okay? So let's get started with just finishing off our last bit about vectors. Do you want me to leave that back on there for a second? No? Okay. So we're just going to do one last thing from vectors, which is to do with the area of a triangle. This should be right at the end of your vectors booklet here. So they've told us that AB is equal to 3I minus 2j, AC is equal to I minus 5j, and we want to determine the angle BAC. And I've called it area of a triangle because once we've worked out the angle of BAC, we can actually then find the area of that triangle as well. So the strategy is to find the three lengths of the triangle and then to use the cosine rule afterwards to find the angle. They've told us that AB, to go from A to B, is 3 minus 2, and to go from A to C is 1 minus 5. If you didn't have that diagram drawn, what you should probably do is for a triangle, you can just put any 3 points on a page. You can label them A, B, and C however you like. They're telling you what AB is, so you can put it in a vector form like that, and 3 minus 2. They're telling you what AC is, so you can put it in vector form 1 minus 5, because the diagram is going to be helpful for you. So if you didn't have that one provided, you would be able to draw it yourself. Just put the 3 points anywhere, okay? For a triangle, it doesn't matter what they look like, you're still going to come up with the same maths. So we need to find out what the lengths of all of these sides are. But before I find the lengths of these sides, I don't know the vector of this side that I've got here. How could I work out the vector of CB using the diagram that I've got here? What pathways would I take, Nabil?
Minus C to A and A to B.
Yeah, I could go from C to A and then from A to B. To go from C to A, it will be this vector, but made negative because it's going in the reverse direction. So it's going to be minus 1 minus 5 plus, then we're coming back down that path in the right direction, 3 minus 2. We can't really do B minus C here just because they don't describe the positions, they're describing the pathways in this case, they're not position vectors. So if we just get rid of this minus bit, it's going to become minus 1, 5 plus 3 minus 2, which gives you the vector. Minus 1 plus 3 is 2, and 5 minus 2 is 3. So I can now add to my diagram that this is 2, 3. And then the strategy is going to be to change this from a diagram that is about vectors and pathways and to change it into a normal kind of triangle question that you might have. So we're going to find the length of these three sides of the triangle. You should all be very quick at finding the lengths. They're all going to be using Pythagoras. So if I want to find the length of this side, it would be the square root of 1 squared plus 5 squared, which is root 26. This one would be the square root of 3 squared plus 2 squared, which is root 13. And then this one would be the square root of 2 squared plus 3 squared, which is also root 13. Now the diagram, in my opinion, is looking pretty busy, so I would like to draw a new diagram that doesn't have all of that information on. I would just like to draw a diagram like this. I don't care if it's this shape of triangle, if it looks like an isosceles or an equilateral, it doesn't really matter because it's just a visual aid for what we're doing. So we've still got the right letters labelled. We've said this side is root 13. BC, maybe I should have drawn it like the other one just to make it match. A bit easier to see what we're doing rather than what's the point of redrawing it crazy. That one is root 13, that one is root 13, and that one is root 26. That's A, C, and B. The angle that they want us to find is angle BAC. Do you know what the instructions, angle BAC, which one it's actually telling you to find? Yeah, the one that's in between. It's telling you to go from B to A to C. So we're actually trying to find this angle that we have at the top here. Now, you may not be familiar with the cosine rule from GCSE because it may have been something that you did in a bit of a rush, but if you are familiar with it, the cosine rule is what we've got up here. We do look at the cosine rule and the sine rule in much more detail later on in the year. So if this is something you go like, oh my gosh, I'm not familiar with this, there will be times in lessons where we explore this in a little bit more detail as well. So we can now say this is the angle that's A that we're talking about here, and A squared is therefore the side that is opposite it. So if we're going to substitute everything into this formula, we will have for our A squared equals B squared plus C squared minus 2BC cos A. we will get that a squared is this one over here, so it's 13, equals b squared, which is this one, it doesn't really matter though, 26, plus c squared, which is the one opposite c, 13, minus 2, root 13, root 26, cos a. Then I'm going to grab my calculator. So we can either put this on that side or we can actually just solve the whole equation. So we've got 13 minus 26 minus 13. So we've got minus 26 equals minus 2 root 13. This is minus 26 root 2 cos a. So if I divide these, I will get minus 26 divided by minus 26 root 2 is cos a, which tells me, if I just come back up here, that cos a is root 2 over 2. That's just from solving the equation and rearranging it to find out what cos a is equal to. And what function do I need to use to find out that angle?
Cos minus 1.
Yeah, cos minus 1 or cos inverse. So a is equal to the inverse cos of root 2 over 2. Does anybody know the inverse cos of root 2 over 2 from your exact values that you should have learnt for GCSE? Good, 45. So a is 45 degrees. Now, this should tell us something about this triangle. Now we can actually draw this triangle a little bit more accurately now that we know it's 45 degrees, okay? If this one up here is 45 degrees, if I just do a sort of a sketch of it, that's going to be 45 here, so that's about 45 like this. And this length, there's A, that's the one that we've said is 45. This length and this length are equal to each other, so I'm going to have to make them look equal to each other like this. So that one must be 45 because this is an isosceles triangle and it's also a right angle triangle. So all of those properties of right angle triangles will work for us as well. We've got the root 13 squared plus root 13 squared is equal to root 26 squared, Pythagoras. And now if I wanted to, I could find out the area of the triangle. How could I, and it's not asked me to do this, but I'm now going a bit beyond the question. What about if I wanted to find the area of the triangle? There's two ways we could do this. What's one of the ways we could do this? We could do a half AB sine C. Now that we've worked out that this is 45 degrees, I could, just using this bit over here, I could use a half. I'm going to put it in inverted commas because you know you can use the letters any way that you like. It's going to be a half. These are my A and B, and again, we'll be looking at this a bit later on as well. A half times root 13 times root 26 times sine 45. That's a half times root 13 times root 26 times sine 45. And we get that the area is 13 over 2 units squared. That's one of the ways we could find out the area of the triangle if we wanted to. I know they haven't asked me to, but it kind of feels like that's what we should have done because that's what the title I put for this slide. I just forgot I didn't put it in the question. What's the other way that you could find out the area of this triangle now that we've drawn the sketch of it? Yeah, just base times height divided by 2, because as soon as you've got 90 degrees in there, you can find out the area in just the traditional way. We could also say that the area of the triangle is base, let's do a half base times height. So in this case, it would be a half. The base is root 13, and the height is root 13, because those are the ones that are perpendicular. So it's a half times root 13 times root 13, which is obviously also not root 13, but it's also 13 over 2 units squared. Okay, so I think we can do just one practice problem that's like this. I will actually just put it on the board for you guys as well. It's from the exercise, so I'll put that up now.